Hello everyone. In today's session, we are going to study in detail about the basic operations of one-dimensional array. In the last session, we have studied what all the operations we can perform on one-dimensional array. But in today's session, we are going in detail about those operations. The first operation is traversal. What is the meaning of traversal? That is the process of visiting each element of an array exactly once is called as traversal. The process of visiting each element of an array exactly once is called as traversal. An algorithm for this operation is, here A is the name of an array and this is the lower bound of an array and the last one is the upper bound of an array. This is a lower bound and this is the upper bound of an array. So the first step is, so it is going to visit each location of an element exactly once. So we are using for loop. For location is equal to lower bound to upper bound. Lower bound to upper bound. So we are performing here process operation. Process A of location. Process A of location. End of for. Step 2, exit. So it starts from lower bound to the upper bound. So after visiting each location of an element, it will process A of location. So now let's write a C++ program to input and output the elements in an array. Program to input and output the elements in an array. I want to store 10, 20, 30 and 40 into an array. Right. So the program starts from --include iostream.h --include conio.h void main yes. What are the variables we have to declare here? We have to declare the variables like I, n, and we have to create an array of size 5. Clear screen, CR. Enter the number of elements. So how many elements I want to store here? I want to store 4 elements. So enter the number of elements. We are asking the user to enter the number of elements. Next, what we have to do? We have to enter the elements now. So, Cout, enter the array elements. Enter the array elements. So, for this we have to use for loop for I is equal to 0, I less than n, I plus plus. Cin A of I. So, we have entered the elements into an array. So, after entering the array elements, what we have to do? We have to display the elements. So, for that, Cout, the array elements are, the array elements are for I is equal to 0, I less than n, I plus plus, Cout A of I. So, it will print all the array elements. So, what is the output of this program? First, what will ask the user to enter the number of elements. So, enter the number of elements, that is 4. Then next, enter the array elements. Enter the array elements. 10, 20, 30 and 40. Next, it will print the array elements now. The array elements are 10, 20, 30 and 40. So, this is how we can accept the elements into an array and how to display the array elements. Next, what is the next type of operation? Next type of operation is searching. Next type of operation is searching. So, what is searching? Searching means the process of finding the location of an element in an array is called as searching. In searching, there are of different algorithms, but the most commonly used algorithms are linear search as well as binary search. Linear search and binary search. Now, let us see what is linear search. So, linear search is nothing but the elements are arranged in a sequential manner. The elements are arranged in a sequential manner is called as linear search. How to perform the linear search? To perform the linear search, there is an algorithm. So, linear search is used when the elements of an array are not in any order. Then we are going to use this linear search. So, the first step is location is equal to -1. So, before starting to search the element, the location is -1. Step 2, for p is equal to 0 to n minus 1. P is equal to 0 to n minus 1. When the search starts, it starts from the first position of an element till the last position of an element. If A of P is equal to element. So if A of position, whatever the position is equal to element, then location is equal to position. Then the location will be that position. Next, otherwise go to step 3. End of F, end of for. What is step 3? If location is greater than is equal to 0. If the location is greater than is equal to 0, then we have to print the location. Else we have to print it as unsuccessful search. Step 4, exit. If the location of an element is found, then we have to print it as location, else we have to print it as unsuccessful search. So now let's trace this algorithm. So I want to search the location of an element 45. Hence the search element is 45. So here first, as it is a linear search, it starts from the beginning till the end of an array. So first it starts from the first position. Hence the value of I is 0. I am comparing the value 45 with 14. So 45 with 14. Is 45 is equal to 14? No. Hence I gets increment. I becomes 1. I gets increment. Now I am comparing 45 with 32. 45 is equal to 32 or not? So this is wrong. Hence I gets increment. 14, 32, 6, 45 and 98. Now I gets increment, hence the value of I is 2. Now it will compare with value 6. So 45 is equal to 6 or not. Hence it is wrong. I gets increment. The value of I is 3 now. Now I am comparing 45 with the value 45, hence they are equal. 45 is found in location 3, hence location, the value of 45, location of 45 is 3. So I am going to print it as location is 3. If the element is not present in an array, then it is going to print it as unsuccessful search. Now let's write a program for this linear search to find the location of an element. So always the program starts with #include iostream.h #include conio.h void main. And what are all the variables we have to declare? We have to declare an array in element as well as position. First, what we have to do? We have to ask the user to enter how many elements we are going to store in an array. So for that we are going to use cout statement, enter the number of elements. So how many elements we are going to store here? We are going to store 4 elements here. Hence I am giving the variable name n here. Next, cout, enter the array elements. Here user is going to enter the array elements. For I is equal to 0, I less than n, I plus plus, C in A of I. Next, what we have to do? We have to enter the search element. So cout, enter the search element. C in element. So after that, what is the position? Position is equal to -1. Next, for loop. For I is equal to 0, I less than n, I plus plus. After that, what we are going to do? We are going to compare the values with the search element. If A of I is equal to element, then it is going to print location or position is equal to I. Break. If location or position is greater than is equal to 0. If we didn't get the element, then it keep on searching for the element. If we got the search element, then it will come out of the loop and then it will print it as If position is greater than is equal to 0, then it is going to print it as Cout. What it is going to print? It will going to print the position, that is element is found in position it will print the position of an element here. Otherwise, it is going to print it as it's a unsuccessful search. So this is the program for linear search. Next is binary search. What is binary search? To overcome the drawbacks of linear search, this binary search concept came into existence. So what is the drawback of linear search? Linear search takes lot of time to search the location of an element. So to overcome that, the concept called binary search came into existence. In binary search, it is used when the elements of an array are in sorted order. If the elements are in sorted order, then we are going to use this binary search. So while performing binary search, what is the first step? The first step is to note down the first and last position of an array. There is an algorithm for this binary search. First step is we have to note down the first and last position of an array. For example, this is our lower bound and this is our upper bound. We can call it as lower bound or low, upper bound or high. So what is the value of low here? The value of low is 0 and the value of I is n minus 1. So note down that low is equal to 0, high is equal to n minus 1. Next, what is step 2? While low is less than is equal to high, we have to find the mid element in an array. While low is less than is equal to high, we have to find the mid element. How to find the mid element? That is low plus high by 2. Low plus high by 2. Next, after finding this midterm, what we have to do? We have to compare the element with the middle element first. Element is equal to A of mid, then location is equal to mid. Then location is equal to mid. Go to step 4. Else, if element is less than equal to A of mid, then low is equal to mid minus 1. Else high is equal to mid plus 1. And what is step 3? If location is greater than is equal to 0, then we have to print it as location, else we have to print it as unsuccessful search. Unsuccessful search. So in binary search, what we have to do? First we have to note down the low and high value. What is the low and high value? The value of low is 0 and value of high is n minus 1. Then to find the mid element, what we have to do? If low is less than is equal to high. So here the value of low is 0 and the value of high is n minus 1. That is 4, hence 0 is less than is equal to 4. 0 is less than 4, hence we have to find the midterm. That is mid is equal to low plus high by 2. What is low plus high? Low is 0 plus high is 4. 0 plus 4 by 2 is 2. So here 2 is our mid position. Here 2 is the mid position. Then what we have to do? We have to compare the search element. Here I have to find the element 4. I want to find the location of an element 4 in an array. I am comparing that element with the mid number. So what is the mid number? Mid element, that is 3. I am comparing 4 with 3. Is here 4 is equal to 3. 4 is equal to 3 or not. So hence 4 is not equal to 3, hence we are going to check whether element is less than is equal to A of mid. If the element is less than A of mid, then what we have to do? We have to perform the search to the left of an array. If the element is greater than the mid element, then we have to perform the search towards the right of an array, that is the right of the mid element of an array. So here the value of element is 4, hence we have to perform the search towards the right of the mid element of an array. So what we are going to do here? If element is less than A of mid, then low is equal to mid minus 1, else high is equal to mid plus 1. Now I is equal to mid plus 1, then I am comparing 4 with 4. So hence 4 is equal to 4, element is found in position 3. Hence the location of 4 is 3 or the position is 3. So this is how we are going to search the location of an element using binary search. Now let's write a program to search the location of an element using binary search. Hash include iostream.h, hash include conio.h, void main. Then we have to declare the required variables here. Int a of 10, I, n, element, position, then low, mid as well as high. These are the variables we require for our program. Next, what we have to do? We have to enter how many elements we require to store in an array. So enter the number of elements. C in N. So next, enter the array elements. Using for loop, we are going to accept the elements from the user. C in A of I. Next, C out, enter the search element. C in element. Then the position is -1. Then what we have to do? We have to note down the values of low as well as high. Low is equal to 0. High is equal to n minus 1. While low is less than is equal to high, then what we are going to do? We are going to find the mid element, that is low plus high by 2. Next, we are going to compare the elements. Element is equal to A of mid, then the position will be the mid element. The position will be the mid element, else if element is less than A of mid, then what we have to do? Then low is equal to mid minus 1, else high is equal to mid plus 1. Is equal to mid plus 1. If position is greater than 0, we have to print the position. And we have to print the position. Else we have to print it as unsuccessful search. This is our binary search program. In linear search is used when the elements are not in any order. Then we are going to use linear search. When it comes to binary search, the elements should be in a sorted order. Then we are going to use this binary search algorithm. Thank you.